Okay, so this first section, we're going to be looking at special trig integrals. I'm not calling it just trigonometric integrals because we're also going to learn a method called trigonometric substitution next week. So these first two problems, I think you guys should be able to tell me what to do already because we've kind of done them already. What do you mean split, Brandon?
Take like one sine of x out of that and make a sine squared of x.
It's the banana peeling thing, yeah? So should we take a sine off? Should we take a cosine off? Should we take them both off? I mean, those are all options. You said a sine, Brandon, right?
Yeah.
I think you're right. I think let's just try it and see what happens. You don't want to memorize a rule here or anything. You just want to try things, and organically you'll figure it out. So he's saying he wanted to peel a sine off so that then u could be what? Cosine. And then the du would be that sine that he's peeling off. That's the technique here, so peeling. There's a sine squared left, though. That's the part that's a tiny bit dicey, but how do you handle the sine squared part? You turn it into 1 minus cosine squared. Basically, this whole section, all you're going to need to do is be clever with identities that you already know. I mean, there's no more to it than that. It's not like a big technique. It's called use identities you know. That's all there is in this section, really. So a couple of them you might not have thought of without me helping you a little bit, or the book helping you. So that's about all there is to it, though. So we'll go like this then. Gabe said to make this 1 minus cosine squared. I think that's what he said. So that now we can do a u substitution. So I'll go with green. I'm hoping this green is not dead like the other one. Yes. Okay, so u is going to be cosine. Derivative of cosine is, of course, negative sine of x. So now we're going to say this integral simplifies into, I'm just going to put that, I better be consistent. We are going to use that a lot in trig substitution, so don't want to forget your dx. So we've got sine dx right there. That's just a negative du. You can put it in front if you want, right? And then we've got, what else? Help me out. And u to the fourth. Any calculus student who's done okay in Calc 1 should look at that and be like, easy, right? Expand, distribute. We just got to distribute. That's all we got to do. So this is just going to be negative u to the fourth minus u to the sixth du. It's just really easy. So negative u to the fifth over 5 plus u to the seventh over 7, right? So that's going to be negative, what was u? It was cosine, so cosine to the fifth of x over 5 plus cosine to the seventh of x over 7 plus c. And there you go. So that one I probably could have, you guys could have figured it out yourself. I wouldn't have had to mess with it much, right? We already did it. Let's look at and see if we need anything else to do this next problem. I don't think so. I'm just going to leave the limits off. That's technically not right, but peel 1 and what's left in here, cosine squared. Oh, we don't want to write cosine squared down. What do we want to write down there? 1 minus sine squared. Right? You guys have an identity sheet at the beginning of your book. You should hopefully remember most of your identities. Like the next technique might seem like it's a little bit tough from identities, but I'll show you a way where you should be able to remember it and pull it out of any time. Like I don't know identities super well from a memory standpoint. I just know a couple. So anyway, we're going to leave this one alone. So what's u going to be? You guys tell me. Sine. I think that's going to work because du is cosine then. So this integral is going to turn into, I'm just going to leave this off. That way we're technically correct. No technicality mistakes. And what do we have in here then?
du.
Should add my dx, right? Let's put my dx back. Okay. So du is coming from these parts, right?
Times 1 minus u squared.
So we've got du times 1 minus u squared, good, Katie, all over square root of u. And if you look at that, you're not like, oh, it's super simple, but you should look at it and be like, yep, break it up. So that's 1 over the square root of u minus what? Use our exponent abilities. One and a half, 3 halves, however you want to say that, right? Because it's 2 minus 1 half. I'll put a du on here just to be technically correct. So then I'm just going to evaluate the antiderivative up here because we got some limits of integration to apply, right? So find the area under whatever this is, who knows. So how do I do this one? Well, u to the negative 1 half, right? Minus u to the 3 halves. I like to write that out because I don't make mistakes that way. So this is going to be 2u to the 1 half, is that right? Minus 2/5, 5 halves. And we will leave off our plus c because we want to actually say that this is equal. So going back to the original problem now, I'm going to go back to black. Say that this is going to be 2 sine, in fact, instead of writing that as sine to the 1 half power, how about we write root sine, because that's nicer, right? Easier to work with. Minus, the other one's just ugly no matter what, kind of, so we'll say sine to the 5 halves. Evaluated from pi over 6 to pi over 3. Of course, this stuff is now done. So plug in with the fundamental theorem, and we should be good. So let's see, we're going to have pi over 3. What's the sine of pi over 3? I better get some triangles up here, right? So 60 degrees, root 3, 1, 2, right? So the sine's going to be root 3 over 2. So that's 2 square root of, oh man, square root of 3 over 2. Is that right? We can clean that up in a second. Minus, the other one's going to be pi over 6. Oh, I should finish putting this one in, sorry. Minus 2/5, root 3 over 2 to the 5 halves power. Minus, now we're going to need to put pi over 6 in, so I'm going to draw a 30-degree triangle. 1, root 3, 2. So that's going to be 2 times the square root of, now the sine of that's going to be a half. Oh, that's nice. Okay. Minus 2/5, 1 half to the 5 halves. Oh man, I don't really want to clean this up very much. I just want to stick it in my calculator. This square root of square root, that's 1 half power to another 1 half power, right? So if we wanted to start cleaning it up, I'm just going to do a little bit and move on. This is going to be 2 times, what's 1 half to the 1 half is 1/4. So that's going to be 3 to the 1/4 over 2 to the 1 half. I'm not seeing a way to simplify this. It's very good. Let me see if I missed something. It's looking yucky. Nope. The book does like, nope, the book just like is, it simplifies slightly more and then just sticks it in its calculator and obtains a decimal. How many decimal places are we always shooting for though? 3. Okay. So stick it in your calculator, get the decimal. Yep. You always want to try to simplify things like that. This time there was some stuff that I don't think we could really do much with, but you always want to try. Because on the AP exam there'll sometimes be multiple choice with some stuff with the unit circle in it. So always try. That time it wouldn't have worked out. So let's look at another one. Here's something that's really similar. Now, let's see if I can do this without looking at any identities or anything like that. So, the peeling technique doesn't really work because if you peel one cosine off, You've got 3 cosines left. If it was cosine cubed, would the peeling technique work? Yeah. Since you have 3 cosines left, it's not like you can use that squared identity to get rid of things. So the peeling technique really works on trigonometric integrals that have odd numbers of trig functions. Does that kind of make sense? That's the rule of thumb. It's not a very hard one to figure out. Even numbers of trig functions, you've got to use another kind of identity. And I think this is the identity that you want. It's in the front of your book, but it's one you should remember. Can you guys help me out? Let's review 2 key identities. One of them we're going to use, one of them we're not. We're going to use the one for cosine. But the double angle identities, do you guys remember the one for sine? That one's real common. You should know it. So it turns a double angle into a single angle. It's a real easy one to remember. The cosine double angle identity has a few different versions. There's only really one that I ever remember because it's just like Pythagoras, almost. Instead of sine squared plus cosine squared equals 1, it's cosine of double x equals. See how it turned it into a single angle? So I've always found that super easy to remember because it's just like Pythagoras except it's minus. I think that one will solve our problem for us. We've got to be a little more clever first, though. So, what do we really want, cosine or sine? We really want...
Do cosine squared times cosine squared.
Yeah, exactly. So we really want a cosine squared. Do you see a cosine squared somewhere?
Yeah, that sine over yes.
So can we take that cosine squared and get rid of the sine squared? I don't want a sine squared too.
Well, then you could just use the other one.
John, you said what?
Yeah, well, sine squared is 4 minus.
Right? In fact, this is where the other versions of cosine of double x come from, if you remember. They come from doing this, and minus minus is plus, so really you have 2 cosine squareds minus 1, right? And that's all equal to cosine of double x. Oh, but Anna said, hey, you've really got cosine squared things right there, right? You could write them separately, peel them apart, or you could really just write it like this, couldn't you? So I think you're probably already seeing the technique now. We have this right there. So cosine of double x plus 1 all over 2 equals cosine squared x. Oh, and that's what we have right there. So this is equal to what? Cosine of double x plus 1 over 2 squared. Or we could write it twice if we don't want to write it as squared, right? That's what Anna was thinking, I think. Same thing. So that's an integral. If the squared wasn't there, we could do it immediately, right? That would be an easy integral. So if you had a cosine squared, I mean, you'd be done right now. So we have a squared thing. What do you guys think we should do with the squared thing? This is a little bit harder problem. Square it. So see what happens. FOIL it out. Expand it. However you want to say that. What's going to come out in front of the integral? 1/4. Very good. And now if we expand this inside, we get the first thing squared. That's where I'm going. Dang it. So we're going to have to do it again. But then the other things will all be things we can do. First thing squared. Last thing squared. Double that times that, right? So plus 2 of those times 1 is nothing. So there you go. That is the purple thing. And now I think we can go, that's 1/4. These integrals are both easy to do. This integral we're going to have to use the trick we just learned again. Cosine squared we just learned is one way to write it is what? So I'm going to go cosine of double something plus 1 over 2 plus this stuff is still here and this 1 is still chilling too. What goes here? Remember, the identity says whatever is in x, double it to put it here. So if I had 2x in there, I need to double that 2x to get 4x here. And now all of those integrals should be something easy. So now doing them piecemeal, I'm going to have 1/4 times, this first one, that's fine. Times, what's the integral of cosine, guys? Maybe I should write this up. Let's do one more step before I do that. So we can show everything. It's going to be 1/4 times cosine of 4x over 2 plus 1/2. That 1/2 and this one can be combined, can't they? So let's say plus 1.5 and just take this and this together, plus cosine of 2x. I'm going to get rid of our friend up here. Say that that's equal to 1/4. You guys help me integrate cosine? What is the integral of cosine? It's just plain old sine of the stuff. Kyle, you say there's a chain rule. How do I handle that? I need another 4 underneath, right? And what else am I missing? The 2 that was already chilling down there. Does that make sense? You can, of course, write your U sub out if you need to. So if you're watching the video and need to, go ahead. I doubt you need to if you're at this point. So plus 1.5x, right? And how about this one? Can you guys help me? Sine of 2x is the answer, because the integral of sine is cosine. You've got a 2. You've got also a 2. You got to worry about the chain rule. Those will cancel. That's what you get. So I think we're done. We just want to distribute our 4th. So this is sine of 4x over 32 plus 1.5x plus sine of 2x plus c. There we go. Yay! Now, say there's a 3/8. Do I have... Oh, I have a mistake. Where's my mistake? What did I not distribute?
You did distribute the 1/4 bacon sine.
This is 3/2 times the 4th is... Man. There, now we're good. Okay, let's do one more. Maybe 2 more, we'll see. Since we have time, we can do a couple more. Okay, next example they had in the book was this one. Let's do this one. So I haven't looked at how to do this. You guys are going to have to help me. Resisting my urge to look. So we got tangent, we got secant. Can we do this? So your instinct, is it a Peely problem or another kind of identity problem? Peely, because why? It's odd. So it's just like that other one, isn't it? So this should go pretty fast. Right? Now what? You want U to be what? Think about what you want. You want U to be that, because that's a problem otherwise, right? So if U is secant, this will work. But du for secant is what? Secant tangent? Do we have a secant tangent? Not yet. Okay, if you're not sure. Tangent will be if I do divide by cosine, so that will be tangent squared, divide by cosine, divide by cosine. So this is going to be tangent of x. I don't know if this is going to work. Let's see. Secant squared minus 1. So if we were doing what we were thinking of doing first, I mean, this might not work. I was thinking of going u as secant, just like that other problem, right? So then du would be not secant squared, but secant tangent. Maybe we should distribute up there? I'm not sure if this is going to work. So we have like a secant x, tangent x. Then we... Yeah, I know. I'm trying to figure out where I can get rid of that, right? So then we're going to have minus 1. Oh, okay.
Well, u equals secant x. Can you just take out 1 secant x, call that u, and then
For the secant squared.
I mean, you can make this u, right? But Gabe's thinking, he's saying, can't you just take one of those? That's what I was trying to do. I was trying to take one of those secants out. So, I don't know, because we need one of them to go right there, right? So I think we're going to have to be more clever. Let's see. Maybe we want to split it up. Should we try splitting it up? This over this. And this over this. I think on this one we'll be good to go, won't we? Because this one would be like that over secant tangent is du. And then we'd have a u. And that one we can do for sure. But what about the other one? I have an idea. Do you guys have an idea? Think. What's the problem? You've got this, right? So we're going to change the bottom. We can't do much with the bottom. It's inside a square root, right? So this is still going to be the square root of u. But we need something.
Other one.
What?
Other one.
What do we need here with this to make this work? We need a secant. And I had it. Can we do that? I think so. And now, help me fix this up now. I think it works. So, we'll see if the book did it the same way, I don't know, but I think our way works, so I don't care. This is root u now, right? Or u to the 1/2. Minus, how many u powers do we have down here? 1.5 is negative 3/2. Yeah, I think it worked. So that's going to be 2u to the, no. 1/2 plus 1 is 3/2, 2/3. There we go. Minus negative 1/2 divided by negative 1/2 is going to go like that. Right? Derek doesn't like it. I don't blame you, Derek. So is that 4?
no, you have to take out that 2 first, because if you were dividing by a negative 1/2, you have an extra 2.
Yeah, I'm sorry. Gotta erase that too. Thanks, Kim. Where you at?
The integral before that. Why did you want it down? Like just straight down? Yeah. How does that turn into just root u? Okay. Yep. Sure.
You good? Alrighty.
I'm just tired.
And then, oh, I know. So then we can write this, you know, like this. So what is u? U is secant, right? So secant to the 3/2 power plus 2 over the square root of secant of x plus c. That was fun. Yay! I don't think they did it the same way.
How big is it?
I don't know. Maybe they did. No, they just did theirs with magic and not seeing the things. They did it the same way, but with a lot of things in their head, and not the U substitution shown. I think I would throw the U substitution on this one. I don't know. It's because the book is, a machine. So our book is a machine. I'm pretty sure it's Skynet up at some level. Should we try one more? Let's do one more. We got time. You guys won't even need me tomorrow. We'll do some more examples tomorrow, but even if I'm not here, you guys should be good on this. Oh, no, let's do this one. I want to do this one. Sorry. Change my mind. This one looks more important. Let's do this one. So, we learned two things, right? So far we've had like two kinds of problems, the purely odd ones and the even ones where we had to use like that hat double angle identity trick. So which one do you guys think this is? Not a Peely one because it's even. Are you sure?
I was thinking
The peeling didn't work. I'm sounding like a 5-year-old here. The peeling didn't work on sine and cosine because like when you take the derivative of sine or cosine, you have like another sine or cosine that's there, right? That's by itself. But if you take the derivative of like a tangent, you get secant squared. So can you do this one with peeling? The answer is yes. But those are the two methods, that you really need to know. Now, there might be a problem or two in your assignment that I didn't do a specific example of. If it doesn't work with peeling, if it doesn't work with the double angle identity, you've got like a whole other page of identities. So like, look through them and find one that works. In other words, go to your toolbox, look around for a tool, and then whack the problem with it. Okay? That's the idea. So there's nothing more in this section. So. I think this is going to work. What's this? I even left it up there. Should have erased that. If you ever forget, though, notice, how many times have I looked in the book to find an identity today? None. And that's not because I know identities better than you. I bet you guys know identities better than me because you practiced them lately. What I know better than you is how to start from like 3 pieces of knowledge and build anything else I need. Does that make sense? And that's what you want to try to do as well. So, it's going to work, right? Like, because, well, maybe not. Can we distribute? I think I'm going to distribute. That one's going to work. This is very similar to that problem we just did. That one, you guys are going to have to tell me what to do. So, this guy. Yay, right? That's what I'm saying. That's going to work. So this is going to be u squared integral. I don't want to put an equals there. So really, I guess I'll put it up here. So really, it's going to be what? Tangent cubed of x over 3. Is that right? So it's the integral of u squared. The u is right there. I should put a dx. And I should put a du right here too. And I should do this in red to be consistent. Jeez. There. From 0 to pi. We can do that in a second. Oh, thanks, Kyle. Somehow this changed for pi over 4. There we go. All right. How do I do this integral? That's what I need help with. You guys tell me, how do I do this integral? Gabe's thinking maybe it's an integration by parts problem. That's possible. I bet you guys will have a couple in there where you need to do parts at some point. I think this is easier. Can we just do it again? You always want to think ahead a little bit. If you do it again, then you're going to have a secant squared there, right? But you know the integral of secant squared. It's just tangent. And you know the integral of 1 is x. So yeah, you know what this integral is too. So this guy is going to be minus tangent of x, because that's the integral of secant squared, minus x. Thanks, Derek. And I think we'll be good. There we go. So let's just evaluate that guy. Not making any more distributing kind of errors, hopefully. So we're going to have the tangent of pi, and that's all going to be cubed over 3 minus, what's the tangent of 0? Doesn't tangent go right through the origin? Oh, yes. Thanks again. Tangent right through the origin is 0 though, right? So we're not going to have anything here. Then we're going to have, oh man, so I'm going to say plus. Be careful with this. I'm going to have negative tangent of pi over 4 plus pi over 4, right? Minus tangent of 0 is 0 again, so that's going to be negative 0. 0 is 0, so that's easy. So this is going to be equal to, what's the tangent of pi over 4, you guys? 45 degrees is 1, so that's going to be 1 cubed is 1, so that's 1/3. Tangent of pi over 4 again is 1, so it's going to be a minus 1 plus a pi over 4. So that's going to be pi over 4 minus 2/3. That's what I got. Yay, I got the right answer. According to Skynet. I'll see you guys tomorrow, or I won't.